Last time we stopped at question. Okay, we have done B. We need to continue to the question C and also D. Have you given it a try? C and D. Find the question B and D. We continue to that. Unit step function. You have to use the second translation property. Okay, second translation property. The formula of the second translation property is Laplace ft minus a ht minus a is e negative as fs. Okay. So this one, before we apply this formula, we have to make sure the signal, okay, the signal t must be in the same form of the unit step function t minus a. Okay, so now t minus a from the unit step function is t minus 3. Okay, t minus 3. So we have to make sure this t and also this t is in the form of t minus 3. So before we Laplace transform, okay, 2t squared. You leave some space for the t. Leave some space for the t plus 3t minus 1 ht minus 3. Okay, leave some space for the t. Okay. 2t squared plus 3t minus 1. Then build up the t minus 3 plus 3. Okay, because we want t minus 3. Okay, we want to have t minus 3, but you have to plus a 3 back. Because we do not change the question, the minus 3 plus 3 is 0. This is still t squared, 2t squared. So here we apply the same t minus 3 plus 3. Okay, once you have filled up the bracket, you can start to Laplace transform. Okay, you can start the Laplace transform by taking out the -3, the -a. When you take out the -a, you will form the e minus as. Okay, -3. Take out the -3, you have e minus 3s. Then here, your signal function. Okay. Once you have taken out the -3, there will be no more Heaviside function. And then here, when you take out the -3, you have t plus 3. T plus 3 squared. Okay. Then goes to this. Once you take out the -3, you have t plus 3. So plus 3t plus 3. Then expand, simplify, Laplace transform. Any questions? Any questions?
-3 was like -4 exponential, right?
Yeah.
But the shipping was very more exponential.
In the bracket. Did you attend the class? The last one? Yes. Okay, when you have Heaviside function and we want to do the Laplace transform, we have to make sure all the t, okay, all the t must be in the same form of t minus 3. So we have to create the t minus t for this t. So you leave some space. Okay, you leave some space for this t and also this t first. Then you fill up the bracket by t minus 3 and then plus 3. Because this -3 plus 3 is 0, you still have 2t squared. We don't change the question. That's why you fill up the bracket with the t minus 3 and then plus 3. Then after that, we will start to Laplace transform. Okay, when we start to Laplace transform, we will take out the -3. Just like the formula, okay, Laplace ft minus a ht minus a is, okay, when we Laplace transform this kind of function, we will take out the -a to form the e minus as. Yes, this is formula. Then what is left in the Laplace bracket? Okay, so once you take out the -a to form this, no more Heaviside function. This will gone. And this one, once you take out the -a, you have ft only. Ft. So Laplace ft is fs. The same goes to this one. We take out the -3 to form the e minus 3s. This one, e minus 3s. And then once you take out the -3, that means no more Heaviside function. And -3, once you've taken out, you have t plus 3. Okay, 2t plus 3 squared.
Yes.
Then once you take this out, you have plus 3t plus 3. Oh,
-1.
yes.
That's why I'm choosing that.
Okay. Then e. Okay, you have to expand this one. So t squared times 2 plus 60 times 2 plus 9 times 2. Okay, and then open the bracket, 3t plus 9 minus 1. Okay, simplify before you Laplace transform. 2t squared. This one, 15t, this one, and this one, 26. Okay, then Laplace transform using the table.
How can I use it?
Huh?
How can I use it?
Table. 2t squared. Okay, 2, the t squared is 1 over s squared. You still remember the table? T to the power of n, t to the power of n, then you get an n factorial over s n plus 1. Okay, so t squared, you get a 2 factorial over s to the power of 3. Okay, 2 plus 1 is 3. Okay, Laplace. Laplace t power of n, you get n factorial over this. You have to refer to the table. Okay, and this one plus 15 t. T is power of 1. So you have 1 factorial, which is 1 over s squared. Plus 26. 26 is the constant, so 26. 1 over x. I'm sorry. Okay, if you refer to the table, Laplace 1 is 1 over s.
That's it. That's it.
Then just define the and this is 224 s cubed plus 15 over s squared plus 26 over x.
That's it.
Yeah, that's it. Okay, if now we look at the last question. T minus. So this one, you have to make sure this t has a t minus pi. Okay. So you leave some space for the t. This one, you leave some space for this t. And then ht minus pi. And you fill out the bracket with t minus pi plus pi. T minus pi plus pi. Okay, now we take out the minus pi. We take out the minus pi to form e minus pi x. Okay, because this is still ft. When we Laplace transform this, we get f in x. Okay, so when you start to Laplace transform left hand side, we Laplace transform the right hand side as well. Okay, I didn't write out the Laplace this function. I go straight to Laplace process. Okay. So Laplace this one, we get this. Laplace this, we get this. So once you take out the minus pi, this one is gone. This one is gone. So you have sine t plus pi. Okay. So sine t plus pi, we do not have a formula for sine t plus a or t minus a. So you have to apply the identity. Okay, identity sine a plus b. Sine a plus b is sine a cos b plus cos a sine b. So apply the identity sine a cos b plus cos a sine b. Okay. What is cos pi? What is the value of cos pi? Huh? Cos pi is
1 maybe?
1.
I think so.
Cos pi is 1.
Maybe.
Negative 1.
Oh, negative.
Sine pi is 0. Okay, so 0 times cos 0. Negative 1 times sine t, we have negative sine t. Okay, negative sine t. So we can factorize the negative. Okay, we can take out the negative. So Laplace sine t is 1 over s squared plus 1. Okay, so this is the answer, e negative pi s over s squared plus 1. Okay, any questions?
Oh, for this one,
This one square. This way, yes. Okay, this one, 2 times 3 times get 16. Well,
thank you.
this I expense.
This S squared plus ABC plus C squared, right?
A squared plus 2ab plus 3 squared.
All C squared.
Yes. Okay.
I know that rule, I know that rule before you guys were expensive. That's why I'm interested.
Ask you questions for the unit step function. This is the past year of the last year. Okay, so some of the books, as I mentioned, some of the books they use U. Okay, some of the books they use H for Heaviside function. So this U is actually same as the H, 2HP minus 5. Okay, this is the H. Okay, the U is same as the H. Just that they use different notation. Okay, this one 2HT minus 5. You know how to Laplace transform 2HT minus 5? Any idea? Because if you look at the second part, this one, I think you know, all of you know how to get this done. You leave some space for this T, and then you insert the T minus 1 plus 1, and then plus this one 1, right? This one I think shouldn't be a problem because this is similar to the exercises that we have done.
Yeah.
And how about this one? 2HT minus 5. There's no T. There's no T in your signal function. Your signal function is just a constant 2.
Yes.
Okay, when there's no T in your signal function, you don't have to do anything. You just factorize the constant. Then you just proceed to do the Laplace transform. Wow. Oh, a little bit. Okay. So Laplace 2HT minus T minus 5. T minus 5. So we factorize the 2. Okay, we factorize the 2, you have only HT minus pi. So here, when we start to do the Laplace transform, we take out the minus pi, right? We take out the minus pi because there's no T here. There's no T here, so we don't have to do anything. Laplace, take out the minus pi, so you have 2e minus pi s, right?
That's it.
And I want to make sure my screen is properly inside the camera. Okay. 2e minus pi s, then Laplace. When you take out the minus pi, there will be no more Heaviside function. So what is left inside this bracket?
H.
H. No more H.
Oh, yeah.
1. You have only 1 because this function is a function that multiplies to 1, right? The coefficient function is 1. So once you take out the minus pi, Heaviside is gone. What is left is 1. So Laplace 1 is
1 over S squared.
1 over x. The 1 over x squared is for t. Okay, so this is the answer. This is 2e negative pi s over s. Okay, this is the simplest unit step function, the one without t.
But this one much easier.
Huh?
This one much easier.
Yes, because you don't have to do you don't have to change the t from the signal function. So that's why you see these questions, it carries only 2 marks. 2 marks. And 3 marks for this. Okay, we look at another year. Okay, this is 2 years back. Okay, there's no unit step function. This one, okay, I think this one shouldn't be a problem. This one also shouldn't be a problem, but this one, what you need to apply to Laplace transform this term. What you need to apply to Laplace transform this second term. Okay, if you look at the appendix, okay, this is the formula given. So which one you have to use for the TE negative 3T or something? Which one? Can you use the first translation? Can you use the first translation? The question is now. This one. This is the you have to Laplace transform this. So this one, you see, this is the product function that's made up of t and also exponential function. T and exponential function. So if you look at the formula, can we use this?
Yes.
Why no?
Yes, yes,
Yes. You have the exponential function, right? You can use this. Can we use this?
Yes.
Why no?
Yes, yes.
Yes. You can also use this because you have t to the power of 1. So you can either choose the first translation or the derivative property. That will give you the same answer.
In the exam, they give me this table. The exam, they give us.
Yes, this one will be given. Okay, so you can use either one. Okay, as what I mentioned, if you want to Laplace transform a product function, and that product function, if it consists of the EAT, we can use the first translation. If it contains the t to the power of n, we can use the derivative property. And since this question, it contains both exponential and the t.
Is
This one, t and exponential. So you can use both. If you just choose one, and which one is simpler? The one with e.
yes.
The first translation, because if you choose the derivative property, you have to do the differentiation. Okay, so this one you can use the first translation. Okay, 5 marks. Okay, next one, EAT t to the power of n sine AT. So what you need?
First one.
Eh?
We use the same.
This product function, it contains of 3 parts: EAT, t, sine to t. Does any one of you go through the slides of OCW? Yes or no?
Yes.
There is one example similar to this product function with 3 functions. Okay, there's one example in the slides with the solution, with the working solution. Okay. So this one, you have to apply the first translation and derivative property. Both. You have to apply both. E negative 3t. Laplace. E negative 3t, E sine 2t. So there are two ways. Okay, either you start with the first translation or you start with the derivative property. First translation, okay, the EAT, and then this is your. Okay, if you use the first translation, meaning that this will be equals to F S. What is your A? What is your A?
-3.
-3. So S minus A will be S plus 3. Okay, so this is what you want. So what is your FT? Your FT will be this one, right?
Yes.
T sine 2t. When we want to Laplace transform, that means we have to apply the derivative property because this is a product function that contains the t to the power of n. Okay, so to get this, I go straight. N is 1. N is 1. That means you have a -1. And then 1 terms of differentiation. And what you need to differentiate? What you need to differentiate? The Laplace transform of this, right? Laplace transform of this function. So when you Laplace sine 2t, you get a 2 over s squared plus 4. Okay, so when you solve, you will get your fs. Once you get your fs, you can get your fs plus 3. Okay, this is the first way. The second way is et sine 2t. Okay, the second way is you start with this one t. Okay, so you start with this t, meaning that I will write in this form, and this 3t. So this is your t to the power of n. This is your ft. If you start with the derivative property, this will be your t to the power of n. This is your ft. So when we Laplace transform this, you have to find the Laplace transform of this part. Your ft is e -3t sine 2t. So to get the fs, you have to apply the first translation, right? You have to apply the first translation because this is EAT. Okay, this is your FT. Okay, so once you apply the first translation to get your FS, then this will be T to the power of n. N is 1. 1 is when you have a negative sign, d over dx, and what you need to differentiate here, that is the function from. Okay, this one I will leave it to you to try. Okay, you can try both ways, see which one is more convenient to you. Okay, you will get the same result from these two. Either you start from the first translation, or you start with the derivative property. You will get the same result. Okay, but anyway, you have to apply the two properties. Okay, two different properties in solving this product function of 3. Okay, that involves the P, E, and by the sign of positive element. Okay, any questions? I just give you a rough idea of how to solve the product function. Okay, the Laplace of product function is three different functions. Okay.
So this is considered as the hard version, huh?
8.
Yeah, 8 marks. So
8
that's what.
Okay, you can refer to the given example from the OCW slides. Okay, I will encourage you to go through the OCW slides because the slides it contains quite a number of examples. Okay, quite a number of examples. In my slide, I mostly include 1 or 2, and the rest are just exercise or hands-on. Okay, now we look at the 3 years back, okay, past year of 3 years back. Okay, so this question 2. Okay, this is a step function, right? This is a step function. Express or write the step function in terms of unit step function. 1 mark. Because this is a very simple one. I hope you still remember how to express this one into a unit step function. This is what you learned in last Monday, right? This is what you have learned on Monday. Okay, 2 plus the second function minus the first, multiply to the HP minus 1, and then plus the last minus the second last, multiply to the Heaviside function T minus 3. Okay, 1 mark. Okay, then compute the Laplace transform. So this is also what you have learned in the on Monday, and also today the first 2 exercises. Okay, 6 marks. Okay, and last 4 years, the question is similar. Similar. You are given a step function, then you need to express the step function into unit step function, then Laplace transform. Okay, this one is inverse Laplace, where we will move into inverse Laplace now. Okay, this is for inverse. Okay, so far we have done the Laplace transform. And now we will start with the inverse Laplace transform. Okay, inverse Laplace transform means that we will inverse. Okay, inverse, you will change the S domain back into T domain. Okay, inverse. So the inverse notation, we will write the L and then -1, the superscript -1. And this -1, it does not mean 1 over. This is referring to the inverse, not 1 over. Okay, now we look at the basic, okay, the simplest one, inverse Laplace. So if you want to inverse Laplace this function 5 over s plus 3, okay, then you have to search from the formula. Okay, 1 over 5 over s plus 3. Okay, 5 over s plus 3. So which formula you have to apply? 5 over s plus 3. Okay, first we will look at the denominator. S plus 3, s power of 1. S power of 1 means that you won't choose all this. These are for s squared. Okay, then we won't choose this as well because s plus 3, we have a plus constant after the s. So you have to choose this. You have to use this formula. Okay, so first step, you have to identify which formula to use. After that, your function must be same exactly in this form. For you, okay, for you to next identify the A, and then you substitute the A value, then that would be your final answer. Okay, so now we are using this formula. Inverse Laplace of 1 over s minus A, you will get EAT. Okay, we will use this formula. So now you match this one, your function, to this one. We need only 1 at the top. We don't need 5. So whatever that we do not need, we factorize. Okay, so this one, inverse Laplace of this function, we factorize the 5. Then we have this. And now compare this one to the formula. Your A is -3. Okay, then you just substitute the -3 here. So you have E -3T. E -3T. Yes, because the 5 is here. So 5 multiplied to the E -3T. Okay. The second example, 3 over s squared plus 4. Okay. So first, we will look at the denominator. This is squared. s squared, and this is a plus. So if you look at from the list, we need the s squared plus. So either this one or this one, because this is minus. Okay, this is more for minus. So next, we will look at the top whether there is an s. If there is an s, it will be cos. If there is no s, it will be sine.
Yeah, no S. That's not.
So no s, right? It will be sine. So we will use this formula. Okay, so first we identify, okay, this is the formula that we are going to use. Then you compare this one to this. Okay, always start from the bottom. Identify your A. What should be your A?
Minus 4.
What should be your A?
Minus 4. 4.
Your A is 2. That's why your A squared is 4. Okay, A is 2. That means we need a 2 at the top. We need a 2 at the top, but what we have is a 3. Okay, so we don't want the 3. Whatever you don't want, you just pull it out, factorize the 3. And then what you need is a 2, right? Okay, you insert a 2, you multiply a 2, but we divide the 2 outside because we do not want to change the question. Okay, we can cancel out the 2 with this 2. So there is no changes. This is still 3 over s squared plus 4. Okay, so whatever constant that we do not want, we factorize. And then you insert the constant that you want, then you divide the constant outside. Now this is matched with this. So the answer for this one, it will be sine 2a. Simplify 3 over 2 sine 2a. Okay? Okay, any questions? Okay, now we try this.
That's good. I only come to the gamma like Okay, this one, which formula you have to use? 12 over s cubed. This one, refer to the list of formula. Which one? First, second, third. Third. We have to use the third one. Okay, why? Because s power of 3. S power of 3. The first one is s power of 1. The second one is s power of 1. Okay, only the third one allows you to have more than one. This one,
more than 2 and above. Okay, 2 and above. So we have to use this formula. N factorial over S n plus 1. Okay. So Ft, it will be inverse Laplace of this function. Inverse Laplace of this function, this one you compare, okay? Always start from the bottom because you need to identify the value of n. What is your n?
2.
Your n is 2, right?
Yes.
When your n is 2, what we need here?
2.
2, okay? We need a 2, but we have a 12. So what we do?
12 outside.
Okay, you can take out the 12.
Yes.
We need a 2. Okay, 2 factorial is still 2. So when you insert a 2,
We put
divide the 2 outside. Okay, or you can just factorize a 6.
yes.
Okay, and repeat. From the function given, okay, you compare the given function to the formula and choose the suitable one. Then always start from the bottom function, okay, s cubed, compared to this s n plus 1. So your n is 2. Okay, your n is 2. So suppose we need the 2 factorial at the top. 2 factorial is 2. Okay, we don't want 12, we want 2. So take out the 12, insert the 2, divide the 2 outside. Then 12 divided by 2, you get a 6. 6. And then inverse Laplace of this one, what do you get? This one, what do you get?
Wait.
This one, you get a t to the power of n, right? T to the power of n. So t to the power of n, your n is 2.
That's
Okay. This is the basic, this is the basic of the inverse Laplace. Yep. Okay, question number 2. Question number 2, which formula? Find a t, because s squared plus that means you have only these 2 choices, s2 plus either cos or sine. But at the top there is no s. At the top there is no s, so it will be sine. Okay, so according to the formula of sine, you should have an a over s squared plus a squared. Okay, you should have this. So now compare to this, what is your a?
3. 3.
Your a is 3. This one. Start from the bottom. Ignore the top, start from the bottom. S squared plus 9 is s squared plus a squared. What is your a? Your a should be 3. When your a is 3, this one should be a 3.
Yes.
We don't want 4.
Yeah.
We don't want 4.
4
So we take out the 4. We insert the 3, right? We insert the 3, then we divide the 3 outside. Okay, we do some manipulation to get what we want according to the formula. Okay, remember, always start from the bottom function because we can easily manipulate the function at the top, but we can't. Okay, it will be hard for us to manipulate the function at the bottom. So we will always start from the bottom, identify the a first, then we manipulate the value at the top. So this is 4 over 3. This is
sine 3.
sine
3.
3t. Okay. Number 3. Which formula? Which formula? EAT. Yes, EAT, because this is power of 1. Power of 1 and followed by a constant. When you have power of 1 followed by a constant, we will use this formula EAT. So according to the formula, you should have 1 over S minus A. Okay, S minus A. So what you need to do?
So our A is -9. We looked at on the top and 3 outside. Right?
Yes. We don't want 3. We need only 1. So take out the 3. And when you compare this again to the formula, A is -9.
Yes.
A is -9. So your answer will be
E -9.
E -9T.
Yes.
You can try number 4.
لا لا كوساين 80. كوساين كوس 80. ليش؟ هي نفسها. اسمع. والله اس بس هناك نفسها. كوس في So in the exam, they give us this formula.
Yeah, formula will be given.
So now it's not need to say that.
Yes, you don't have to memorize. You just need to know how to apply.
Yes, exactly. That's what So for this one, sure, we use
Yes.
This time we
Which one? Number 4? Which formula? Cos 80, right? Cos 80, because this is S squared plus, and there's an S at the top. So according to the formula, you should have S over S squared plus A squared. Okay, so you inverse Laplace this function. So compare the top function. We don't need the 4, so you take out the 4. Then what is your A? What is your A? Your A squared is 5. What is your A? Square root of 5. Okay, so search 5. When your A is search 5, meaning that the answer will be cos 35t.
Yes.
Because this is s squared plus, and there's no s at the top. So we will use the formula for the sine AT. So for sine AT, the formula is a over s squared plus a squared. Okay, now look at the bottom function. According to this, we want only s squared. The coefficient function is 1. But we have 9. So what we do? Take out the 9 from the bottom. Take out the 9 from the bottom. Okay, this one, I think I write one more line. When you take out the 9 from the bottom, you have s squared plus
2.
4 over 9. 4 over 9. Okay, when you multiply this back, you get 9s squared. Multiply to this, cancel out the 9, you get 4.
Yeah.
Okay, so this one, okay, so 9, we bring it up. When you bring it out, it will be 1 over 9. 1 over 9, because this is from the bottom. Okay, and here we don't want the 3, because your 8 is not 3. We take out the 3. Okay, 3 over 9, we take it out. What is your A now?
2.
What is your A now? Your A squared. This is your A squared. So your A is 2 over 3. We insert a 2 over 3. Outside will be 3 over 2. Because we have to make sure they can be cancelled out. Okay, or 1 over this one, 1 over 2 over 3. Okay, 1 over 2 over 3 is the same as 3 over 2. Okay, now simplify. 3, 3, 9, cancel out the 9, so we have 1 over 2. And what is this? Sine 2 over 3 t. Okay, do not forget about the t. Sine. Sine. Because we have s squared minus and there's no s at the top. So this one, hypersine. Hypersine, so meaning that we need to have a over s squared minus a squared. Okay, so what is your a? Your a is? Your a is 3. Your a is 3. So you should have a 3 here at the top. So you insert a 3, you divide the 3 outside. Okay, hypersine 3t. Done this? When it's 4, up here you need a 4 factorial. So outside 1 over 4 factorial. What is 4 factorial? 24. So this one will be t to the power of 4. Okay.
Doctor, how is 4 factorial 24? How is
4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. You can use your calculator. There's one function. One.
yeah, cos HIT.
Okay. So your A is 2. Okay, your A is 2. And up here we need only S. We don't need the 5. Take out 5. And your A is 2. So this is hyper cos 2t. Okay, very simple. Okay, last one, number 9. Which formula? Exponent. Okay, exponent. Because s power of 1. S power of 1 and it follows by a constant. So when we use the EAT. Okay, so 1 over s minus 8. So what you need to do? Take out the 1 over 2. Take out the 1 over 2. So you have, after you take out the 1 over 2, what do you have? S minus 3 over 2. Correct. Then 1 over 2 E 3 over 2 T EAT. EAT. Your A is 3 over 2.
How is our A 3 over 2? That one.
This one.
How is it 3 over 2? How we have 3 over 2?
How?
So, A, the question.
Oh,
One.
this one.
Yeah.
Because this function is equals to 2 s minus 3 over 2. Factorize the 2. Right? 2s and
Yes.
any questions? Okay. We look at the first property. The first property of the inverse Laplace. Is the linearity. The linearity is simple, meaning that when you have a constant multiplied to a function, we can factorize the constant. When you have a linear combination of functions, we can separate them individually. Okay. Okay, for example, this one, if you have a fraction function, something like this. Okay, this one, when we do the inverse Laplace, we have to break this into 2. Why we need to break this into 2? Why? Because your formula, okay, it doesn't contain the function something like this. Okay, this one Okay, this one, if you look at the bottom function, this is for either cos or sine. Okay, cos or sine. But here, one is with s, another one without s. So we have to separate them because one for cos, another one for sine. That will lead you to the different function. Okay, that's why we need to break this into two. Okay, once you break this into two, then you just continue with what you have learned just now.
Yes.
Compare, first identify which formula to use, then compare your function to the formula and do some manipulation, then you get the result. Okay, just like this one, A is 5. You should have a 5 here instead of 7. So you bring up the 7, insert the 5, divides the 5. Then you will get the result. Okay?
Yes.
Okay, exercise again, hands on. You break the function into two, then inverse Laplace correspondingly. Separate this one into two. One for 4x, another one for 5. You should be able to come up with the final answer.
Yes.
Okay, so the first term, it should be
Cos T.
cos. Okay, cos. So we take out the 4, we have a cos 2t. And the second term is
Sin T.
sine. Okay, sine. What we need here, what we need here for the sine,
2.
we need a 2.
Yes.
Your a is 2.
Yes.
A squared is 4, your a is 2. We should have a 2. We don't want 5.
Yes.
Take out the 5. You insert the 2, divide the 2 outside. Then you get the answer. 5/2 sine 2t.
Yes.
Okay. And number 2. Okay. So number 2, separate the functions. Okay. Number 2 is similar to number 1. Okay. So what is this? Hypercos. Okay, hypercos. So hypercos, take out the 3, hypercos 5t. Okay, your a is 5. Okay, minus, okay, this is also hyper, but hyper sine. Hyper sine, so your a is 5. So we don't want 6, we want 5. Okay, take out the 6, insert the 5, then divide the 5 outside. But when you write down the answer directly without the steps of this 6 and then 1.5 5/s² minus 25. Okay, so if you didn't write this up, sometimes it may leads to careless mistake. So if you want to write down the answer directly without this step, make sure you do not forget about the value that you insert into the function, then you divide outside. Okay? Normally, students make careless mistakes here. They take out the value, then forgot to divide the value that they insert into the function. Normally, careless mistake happens there. Okay? So if you want to skip this, okay, make sure you remember, okay, divide outside with the value that you inserted into the function. Okay, number 3. At the bottom, the coefficient function is not 1. So you have to factorize the 4 from the bottom. Okay, factorize the 4 from the bottom, meaning that you have 1/4. Okay, then your bottom function will be s squared plus 9/4. Okay, then at the top you still have s plus 3. Okay, factorize the 4 from the bottom function, then you get 1/4. Okay, 1/4. Here it will be s squared plus 9/4. Okay, then only you separate. So this is what function is this? Cos A is 3/2t. Okay, plus the second term. This one, your A is 3/2. We need 3/2. We don't want 3. So take out the 3, insert the 3/2.
We put 3/2 there.
Then this will be 2/3.
1.
So 2. This is sine 3/2t. Cancel the 3. Cancel the 3. Get 2 sine 3/2t. Okay, last one. So number 4, what you need to do, take out the 16 from the bottom, so you have 1/16. So your bottom function will be
S minus
minus
9. Minus 3.
minus
9/16.
9/16. Okay. Next, separate. Okay. So what is this?
Cos 8.
Hyper
Cos 8.
cos. Okay, hyper cos. So take out the 3, you have hyper cos 3/4 plus, okay, we need a 3/4 at the top, so take out the 5. We want a 3/4, meaning that here we 4/3. Okay, 20/3 hyper sine 3/4t. Any questions? Is it simple? Okay, now I want you to go to the WhatsApp group to open the link that I sent yesterday for section 2 and complete the exercise at the Microsoft form. Okay, go to the WhatsApp group, our WhatsApp group, click on the link.
Yes. So you are الأول ستة ناقص بي 8 سي نعم طب توريني انت اللي توريني ستة ناقص بي 8 سي زائد 3 اي ماينس 5
Consider simple and normal. So if you got the wrong answer, then I believe that it comes from your careless mistake. Okay, so when you check back, it's the answer that you got wrong. Are you able to understand where is your mistake? Do you want me to discuss any of this? Any of the questions from this? I think eight questions.
Because I did try to forget what number I it's not in my mind, you know.
Yes, then I'll see you next week.
Eso